so here's the rest of the variation notes. In class next time, I will be checking all of your variation notes to make sure that you've got them complete from start to finish, including all of the try me problems. So we're going to talk about joint variation, which is really just a combination of different types of variation. It says if y varies jointly with m and n, or is jointly proportional with m and n, then we write y equals k n n. That's a bit of a distraction because it's not always k times m times n. Frequently we'll change what we're doing to the variables, or sometimes we do a combination of direct variation and inverse. So I wouldn't worry about trying to memorize that as a formula because you're not going to adhere to it strictly. So let's look at an example. Example 9 says to write the equation of variation to fit the situation. Since we don't have any numbers, we're just going to write that general form. So the lateral surface area, which they're asking us to use S for, varies jointly as its radius and height. So we would say S equals K times R for radius times H for height. That would be the general form. Then if we had numbers, we could substitute them in for S, R, and H, find K, and go on from there. So let's look at B. The area of a regular polygon varies jointly as its apothem and the perimeter P. Since we're going to use A for apothem and P for perimeter, let's use R for regular polygon. So R would just equal K times A times P. Make sense? All right, so let's go ahead and look at a full example now. Notice the bold type. It says you need to pay attention to the wording in the problem for any adjustments you need to make to the variable. Expect to have to do that. All right, so step 1. We need our general form. The maximum weight that a circular column can support is directly proportional to the 4th power of its diameter and inversely proportional to the square of its height. We're going to translate that into the general form. I'm going to use W for my weight. We're going to use D for diameter, and we're going to use H for height. So it tells me that the weight is directly proportional, so K times the 4th power of its diameter, so D to the 4th power, and inversely proportional to the square of its height. So H squared is going to go on the bottom. You always keep these things together. We're not going to have 2 separate K values for each of those, because even if we did have 2 K values, we would put them together and still just create 1 K value. All right, so now what we're going to do is find out what that constant of proportionality is. It tells us that a 2-meter diameter column that's 8 meters in height can support 1 ton. So let's use that to find K. All right, the weight that it can support is 1 ton, so we're going to go ahead and put a 1 here. The diameter, it's a 2-meter diameter column, so we'll do 2, and diameter is supposed to be raised to the 4th power. H, it's 8 meters in height, and that needs to be squared. So from here, we just need to simplify this a little bit and solve for K. So we would have 1 equal to 2 to the 4th, which is 16, over 8 squared, which is 64. So we have 16K over 64. So I can go ahead and reduce that fraction. I think that's going to make it easier. They're both divisible by 16, so that would be 1/4, or just K over 4. So then we can see very easily that K would be 4. All right, so let's reset our equation now. Now that we know K, that makes our equation look like this. And our last step is our task. They want us to find the weight that a 1 diameter meter column can support if it's 4 meters in height. So we're finding weight. 4 is our constant of variation. The diameter is a 1 meter in diameter, so we're going to have 1 to the 4th power. It's 4 meters in height, so 4 squared. So this would be 1 to the 4th, which is 1, times 4 is 4. 4 squared is 16, so W comes out to be 1/4. So our answer would be 1/4 of a ton. The next problem is a try me problem. I want you to read through this, try to set up the general form, plug in your numbers, find your constant of variation, reset, write your equation of variation, and then answer the question. Stop the video, complete this, and then hit resume. Okay, let's go ahead and check this and see how you did. Suppose that y varies directly as z and inversely as the cube of x. This is what your general form should look like. Then we're going to use that complete set of information to find our constant of variation. So y is 15 when z is 5 and x is 3. Okay? So if I go to simplify this, I'm going to have 5k over 27. So basically to solve, I'm going to have to multiply by 27 and divide by 5. So if I think through this, multiply by 27, divide by 5, to do this easier, I'm going to go ahead and do my division first. Then that makes this 81. So we can see that k is 81. So now let's write our equation of variation. We would have y equals 81z over x to the third. Finally, let's look at our task. Oh, that was our task. They just wanted the constant of variation and the variation equation. So 81 is your constant of variation. And this right here is your equation of variation, or your variation equation. Okay, at this point what I want you to do is work on your 5H assignment and do the variation. The front side, most of that is very, very short, so make sure that you're reading directions and not trying to go too far with it. So you'll work through that assignment and turn it in when you're done. After that, you can start working on your test review. Your assignment by next class is to have the odds in your test review completed. That way I know you've kind of looked at everything that you need to be doing, you'll know where your questions are, and you'll have a good start on the review. If you have any other questions, you can email me and I will be around tomorrow. Good luck.